Here is a matching type question on general organic chemistry. Study the items in both columns carefully. Try to work out the matching before we solve it together. Let us first understand the key concept here. Carbocation stability depends on a. Degree of substitution, 3 degrees greater than 2 degrees greater than 1 degree, b. Allylic resonance stabilization, and c. The number of resonance structures available. Moving on to the next step. Carbocation A, the positive charge is at a 3 degrees carbon that is doubly allylic. It is in conjugation with 2 double bonds simultaneously. The structure is a bicyclic system where the cationic center sits between 2 alkenes. This means the positive charge can be delocalized over 3 carbons via 2 resonance structures, or equivalently, it is a cross-conjugated extended allylic system. Being 3 degrees and doubly allylic makes this very stable, but the geometry of the bicyclic system means both double bonds may not be simultaneously in full conjugation. Still, it benefits from 2 allylic interactions plus being tertiary. Carbocation B, the positive charge is at a 2 degrees carbon that is allylic to 1 double bond, but the ring system also has a second double bond nearby, labeled 3 degrees carbons on that alkene. The cation at 2 degrees allylic position is stabilized by resonance with 1 double bond. However, the second double bond in the molecule may provide additional homoallyc or extended conjugation. Crucially, looking at the labeling, the plus 2 degrees carbon is allylic, and the structure suggests the cation can delocalize into positions labeled 3 degrees, meaning resonance moves the charge to a 3 degrees carbon, making this effectively a 3 degrees allylic cation through resonance. This makes B the most stable, rank 1. Moving on to the next step. B is equal to rank 1, most stable 2 degrees carbocation allylic to a double bond where resonance places the charge on a 3 degrees carbon, effectively a tertiary allylic carbocation. A is equal to rank 2, 3 degrees carbocation doubly allylic, very stable but slightly less than B because of geometric constraints or because the effective resonance contributor places charge on 2 degrees carbons. C is equal to rank 3, 3 degrees carbocation that is allylic to 1 double bond, tertiary allylic, good stability but only 1 allylic resonance. D is equal to rank 4, least stable 2 degrees carbocation that is not allylic, or only weakly stabilized, no resonance delocalization into a double bond, making it the least stable. And for the final step, D cannot be more stable than C because D is 2 degrees non-allylic versus C being 3 degrees allylic. A cannot be rank 1 because although doubly allylic, the resonance contributors place charge on 2 degrees carbons, whereas B's resonance places charge on a 3 degrees carbon. C cannot outrank A because A has 2 allylic interactions versus CS1. Therefore, the correct answer is A 2, B 1, C 3, D 4. Therefore, the correct matching is A matches 2, B matches 1, C matches 3, D matches 4.